Standard 11 Chemistry, Unit 3, Classification of Elements and Periodicity in Properties, Part 12, Trends in Chemical Properties. Here we discuss about valence or oxidation state. Valence or oxidation state, number of electron in outermost orbital. For example, sodium and its atomic number is 11. Its electronic configuration is 1s2, 2s2, 2p6 and 3s1. So 3s1 is outermost orbital and it has only one electron. To complete its octet, it loses one electron. Whenever it loses one electron, it is converted to sodium ion or it is cation. So this makes it very stable conditions because now it has two in first cell 2 electron and in second cell there are 8 electrons. This makes it to stable condition. So here this is the charge, sodium for plus 1 charge, and it is called its oxidation state or its valence is plus 1. Okay. Now for noble gas, here helium, its atomic number is 2. In there are 2 electrons, so it is the exceptional case for octet rule. It is called duplet. Now for neon, its atomic number is 10. Here in first cell 2 electron, then after in second cell there are 8 electrons. Here is the most stable arrangement. And that is octet. Okay. Now then after neon and argon, 18, 2, 8, 8. For krypton 36, its electronic configuration will be 2, 8, 18 and 8. For xenon Xe, its atomic number is 54, 2, 8, 18, 18 and 8. Now for radon 82, it's 2, 8, 18, 32, 18 and 8. Here for neon, argon, krypton, xenon, radon, in outermost shell there are 8 electrons. They do not undergo any chemical reaction or they do not react with any other substance, or therefore they are inert gas. Do not undergo any chemical reaction or react with any other substance. So that's why they are called inert gas. So all the atoms of the elements, to complete its octets, it loses or gains of electron or shares electron. Here for second example, suppose this magnesium, its atomic number is 12. Now its electronic configuration will be neon 3s2. Okay, to complete its octet it loses 2 electron. Okay, for aluminium 13, neon 3s2 3p1. In outermost cell there are 3 electrons. Okay, 2 plus 1, there are 3 electrons, and it lose to complete its octet means here electronic configuration like 2 8, it's neon. Okay, so it loses 2 electrons. So they are called metals. Okay, and their valence electrons are 2, their valence electrons are 3. So valence electron, if the valence electrons are like 1 2 or 3, for here sodium 11, its electronic configuration will be neon 3s1. Okay, so there is only one electron. If valence electron is 1 2 or 3, in order to stabilize, in order to satisfy its octet, it loses electron, and they are metals. Okay, so for another example, suppose for sulfur, atomic number is 16. Now its electronic configuration will be neon 3s2 3p4. Okay, so in outermost shell there are 2 plus 4 6 electrons. To complete its octet, either it loses 6 electron or it gains of 2 electrons. So it is easily to gains 2 electron, and it completes its octet like or argon. Whenever sulfur gains of 2 electron, now its electronic configuration will be neon 3s2. So this electronic configuration is like R1. Okay, so here it gains 2 electron to complete its octet. Okay, this for in case of 2 electron. Now in outermost shell there is 6 electrons. Okay, for chlorine, suppose chlorine 17, neon 3s2 3p5. In outermost shell 2 plus 5 means total 7 electrons. To complete its octets, it gains of 1 electron. It gains of 1 electron. When it gains electron, it is converted to anion or negative ion. Okay, right? And whenever it loses 1 electron, 1, 2 or 3 electrons, they are converted to positive ion or negative ion. So here for sulfur or chlorine, there are 2 electrons gains, or 1 electron is gained. For suppose phosphorus 15. Okay, electronic configuration will be neon 3s2 3p, sorry, here 3p3. Okay, 10 plus 2 uh, 12 plus 3, total 15. So in outermost shell there are 5 electrons. To complete its octane, it gains 3 electrons. Whenever it gains 3 electrons, it is converted to, there is -3 charge. So when 5, 6 or 7 electrons, it gains a electron, and they are all phosphorus, sulfur, chlorine, they are non-metals. Okay, now for suppose here silicon, here its atomic number is 14. Its electronic configuration will be 3s neon 3s2 3p2. Now in outermost shell there are 4 electrons. To complete its octet, either it gains of 4 electrons or it loses 1 electron. When it gains 4 electron, its electronic configuration is similar to argon, or when it loses its electron, its electronic configuration will be similar to neon. So here it shares of electron, either they shares the electron. And here in valence cell there are 4 electron, they shares electron, and they are metalloids. Okay, so from this example, the valency is nothing but the number of electrons gain or loses or shares, so as to make the octet of electron in outermost cell. Okay, valence electron, there is either 1, 2 or 3 valence electron loses, and there valency will be either there is one electron it loses, there will its valency will be Na plus, and for example here for sodium there is one valency. Okay, for here if there is two valence electron, it loses two electron, its valency will be plus 2. For example Mg2 plus, when valence electrons are 3, it loses 3 electrons. When it loses electrons, they are converted to cation, and now they loses 3 electrons. For example aluminium 3 plus. Okay, now this is the concept about whenever it loses electron, now gains, there is 5, 6 or 7. 5, here it requires 3 electrons to complete its octet, so its valency is minus 3. Here if there are 6 valence electron, it, to complete its octet it gains 2 electrons. Whenever it gains 2 electrons, it's there is minus 2 valency. Or for 7 it gains 1 electron, there is valency is minus 1. For example here suppose Cl minus, it's chloride ion. Here for S2 minus sulfur or phosphorus 3 minus. Okay, okay, so this is the concept about the loss of electron or gain of electron and their valency. Now there is some variable valency. Certain elements exhibit more than one valency of here in some elements loses the electron from the valence shell or inner shell also, it loses electrons from valence shell or inner shell also. So they exhibits the variable valency. For example here Cu plus 1, or it is written as Cu into bracket Roman letter 1, and the another Cu2 plus, or it is written as Cu in Roman letter 2. Okay, so here which one is copper ion is the main question. Copper is the variable valency, either it loses 1 electron or 2 electron. Now plus 1 is lower valency. Okay, so whenever it's lower valency, its suffix will be OUS. Now its name will be cuprous. Okay, or whenever the higher valency, here it's plus 2, that is higher valency, its suffix will be ic, ic. So this the cupric ion is called cupric ion. Okay, is cuprous and the cupric. So Cu plus 1, Cu plus 1, it is named as cuprous, and Cu2 plus it is named as cupric. Okay, so please remember these things. This is the suffix. When lower valency, this suffix will be OUS, and the higher valency for particular one atom of the elements. Okay, so higher valency is IC. For some, suppose here Fe2 plus and Fe3 plus. Ferrous exhibits two valency here, Fe2 plus and Fe3 plus. Now which one is ferrous or ferric? Here Fe2 plus is a lower compared to Fe3 plus, so it's higher valency. Whenever lower valency, its suffix will be OUS, and from ferrum, from the Latin name ferrum, its sign will be Fe. Now its name will be ferrous. It's now it's a ferrous ion. Okay, now Fe3 plus is ferric. Okay, now for Ag plus or Ag2 plus, now it's called argentinous. It's a silver metal, and here argentic. Okay, or Hg plus or Hg2 plus. Hg mercury hydrargyrum, its Latin name will be hydrargyrum. From hydrargyrum, its sign will be Hg. Hg plus is a mercurous. Its name will be mercurous, and here plus 2, it's a higher valence, it is mercuric. Okay, or Sn2 plus and Sn4 plus. It is a tin metal. It's a tin metal, but it is stannous. Its name will be stannous. Sorry, Stannous. Or here its suffix will be ic, or stannic. Okay, and this is the concept about the valency. And the last, that sometimes you will be asked, oxidation state, or in another word, charge on atom of element. For example, Na plus, its charge will be plus 1 charge, so its oxidation state is plus 1. Okay, so oxidation state means in charge on atom of the element, or it is loses or gain electrons. For chloride and Cl minus, its charge will be -1 charge. Okay. So here as per S block elements, their oxidation numbers will be +1 is for alkali metal, or for oxidation number +2 is for alkaline earth metal, or P block element possesses positive and negative oxidation number, O n. Okay. For D block, it possesses more than one oxidation number, more than one oxidation numbers. Now the trends in oxidation state according to electronic configuration and screening effect. Here for group and its electronic configuration, their valence electron or their oxidation state. Here for group 1, their electronic configuration is NS1, is for a last or outermost cell or orbital. Okay, their valence electron will be 1 and its oxidation state will be +1. For group 2, its electronic configuration will be NS2. Valence electron is 2, oxidation state will be +2. For group 13, NS2 NP1, valence electron is 3, oxidation state will be +3. Or another oxidation state, there will be +1, or it is boron group. Okay. For 14, NS2 NP2, 2 plus 2, valence electrons are 4. There will be -4, -2, +2, +4 oxidation state, and they are carbon group or carbon family. Group 15, NS2 NP3, 2 plus 3, 5 valence electron. Their oxidation state will be -3. Or another oxidation state for +3 +5, it is nitrogen family. Or 16, NS2 NP4, 2 plus 4 6, there will be minus 2, or another oxidation state will be plus 2 plus 4 and plus 6. They are, for example, chalcogens. Or group 17 is a halogen group, NH2 NP5, 2 plus 5 7 electrons. Their oxidation state, it requires 1 electron, so it gains of 1 electron. Their oxidation state or valency will be minus 1, and plus 1 plus 3 plus 5 plus 7, or halogen. Here 18, group 18, NH2 NP6, 2 plus 6 8 electrons. So this the noble gas or inert gas, so their oxidation state will be 0. Is erosions. Okay, so these all the concept about the valence electron 1 2 3 4 5 6 7 and 8. Okay friends, so next time we will discuss another topic. Thank you very much.